All right, so thank you everyone for coming to my talk. Good morning. My name is Liran Tal. I'm a developer advocate at Snyk, where we build free developer security tools. I'm also involved in a bunch of security research, disclosing vulnerabilities for NPM packages, and just generally doing some fun stuff with JavaScript with everyone here, which is also a really good opportunity to basically thank all of you for being here and just thank Nearform, thank everyone in our very welcoming and supportive JavaScript community who I've been lucky enough to collaborate with, learn from, and just build silly JavaScript things together. So thanks to all of you. So as developers, we are often made aware of the general public concern of application security issues. Things like vulnerable NPM packages, malicious actors on the ecosystem. We see those news, we see these things kind of coming up now and then. And so today, what I wanted to do is really take a moment to just kind of share my experiences of a specific code security issue, Path Traversal vulnerabilities, and kind of talk also about why this is such a significant security concern that is impacting everything from web applications to routers and maybe cars, but essentially have very devastating implications on these web applications. So hopefully, after this talk, you will be able to recognize vulnerable code, see those patterns, and then apply those day-to-day in your coding habits at work. So with that, I think we kind of need to define and kind of like demystify what is actually Path Traversal. And so to understand that, this is kind of the Wikipedia dictionary definition of Path Traversal, which is also known as directory traversal. But if we call out very specific things and highlight what's like really important here is the idea of this being a vulnerability is essentially because of insecure coding practices, such as not validating input that is actually user supplied and is related to accessing files. And that goes straight into things like accessing the file system API, which is a very sensitive operation for operating systems or just essentially applications. And the outcome of that is, of course, the fact that we're actually being able to traverse a file path and access paths that we shouldn't have to begin with. So how does it look like in practice? How do you execute a Path Traversal attack? Well, it is a very simple attack to execute in essence, right? You simply put in an HTTP request, shoot it out, you define your Path Traversal path with those //slashes, so you try to traverse up to a directory on the server that is potentially not protected as it should. And if you are successful of doing it, and you potentially hit something like config JSON, which is very common asset in web applications, then you might be able to access things like this database credentials for a server and so on. But why are we talking about Path Traversal to begin with? Because vulnerability reports that we're seeing day to day are cross-site scripting and code injection and prototype pollution. So what makes Path Traversal so important for me to talk to you today? It's not even on the OWASP top 10 document, which is an awareness document that lists all of those top 10 web common security weaknesses that we should be aware of. It's not even here, despite being injection, having insecure design, vulnerable and outdated components, but Path Traversal is not here. So we kind of need to understand what are the two main concerns, in my opinion, for Path Traversal. They are essentially, I've divided them into two categories. One is the fact that with Path Traversal happening, you have access for very much sensitive information on a server running this, right? So you can access things like that config JSON thing if you have it, or that env file, or your node modules, and I can actually see the code of the node modules, or your package JSON, and then find out which outdated dependencies you have that I can actually then escalate the attack, or your SSH keys if this is some servers that connecting to other servers, and so on and so on. And so that actually relates to another issue, which is the one on the right, the vulnerability chaining, which is an actual security term from the CVSS document that says I can I can start off an attack with Path Traversal, but due to all of the information around it and the insecurity of an application, I can escalate that to things like remote code execution and far more worse scope of attack. So let's see some examples in the wild and then dive into how this actually happens in other cases. So Zimbra is a mail server that's kind of like oftenly used by maybe vendors and enterprises and so on. And it was found vulnerable to a Path Traversal attack. Imagine mail server, you send files compressed, You need to uncompress them, do something with them, and so on. But that actually elevates the scope of this attack to an unauthenticated remote code execution. This is really recent vulnerability, as you can see by the CVE date from 2022. And it's so widespread and potentially harmful due to Path Traversal and its elevated scope that the CISA, which is a US government agency related to cybersecurity, has issued an alert and a report to basically advise everyone to upgrade and apply fixes. In fact, you would imagine that smart people who build HTTP web servers all day, not just general Node applications and CLIs or whatever, would get Path Traversal right? Like for 30 years or whatever of building the HTTP Apache web server, there are still all the time Path Traversal vulnerabilities, and these are really smart people building this, and this is a web server. Like it's, by definition, its very core path of work is to work with paths and URLs and whatever. And so even more, I think, important to see here is how it is a little more complex than maybe potentially other vulnerabilities to even fix, because this specific CVE happening last year affecting this web server not only been categorized as critical severity, but also if you look at the actual change logs and the details, this is related and due to an incomplete fix of a different Path Traversal vulnerability that was applied before. So it even wasn't really straightforward how to fix this. How do you attack a web server? Well, that web server is specifically vulnerable to this kind of payload. Again, it looks simple and it looks harmless, but it isn't, right? It's very potentially devastating. So you apply this payload to a vulnerable server of that version, and you can access these kind of files on the server. In fact, I didn't really need to do much to find this payload. I just searched on Twitter, and there are a lot of, you probably follow a lot of people on the dev side of things. Well, there are a lot of, InfoSec and kind of like black hat people out there on Twitter as well, and I've actually shared, and I can share the Twitter link afterwards, but if you can notice the bit of the green and black background there, that actual payload that they share there is affecting this server, but is actually escalating the attack to run an ID command on the Linux server. So, this is kind of what we need to deal with and protect against. So I wonder at this point, if we're getting Path Traversal APIs and just general file path APIs for granted, are we just taking them for granted because their differences and nuances are very, very small. They're very subtle between what a path join is, how is that different from path resolve or normalize, how do they work differently, what's the actual potential pitfalls with any of them. So with that, kind of to begin with here, why am I at all vulnerable if if we look at code, why is that code vulnerable to begin with? How do we avoid different permutations of Path Traversal happening for us? And then, trying to provide you with this talk some secure coding practices of how to implement them in your day-to-day code so you are not vulnerable to Path Traversal in the future. So what a better way to learn than, looking at vulnerable code and, trying to understand, what the fix was, why was it vulnerable, and so on. So here's some Path Traversal in an NPM package. This specifically is affecting a package called ST, which eloquently has described itself as a module for serving static files. It's pretty popular, existing for a while on the ecosystem and having a bunch of downloads per week, about 500,000 of them. So it's pretty useful. It's used to serve maybe CSS or images or whatever you want to serve. And its usage is also pretty simple, right? If you have an Express application, you use it as an Express middleware thing. You provide the path to things like /public. You provide the URL, which is where you want things accessible, and you fire it off, and that's it. It's going to go and serve all the static files. Well, what if we try to attack it? What if we try to then push in an HTTP request with a // and try to access the Node test app that I have here? Would this work? Luckily, it doesn't. At this point, this doesn't work. But why doesn't it work is why this is interesting. So I looked ahead, looked at the ST codes, and here's the actually important information out of it that handles all of this Path Traversal things. So there's a get path function in this module code, and what essentially it does, and we'll walk through it as a kind of simple debugger simulation here, it gets the URL that you're actually requesting, /public // package.json. That is then handed off to a URL core module that then parses the URL and tries to access path name to essentially extract that information. There's more regular expression parsing being done here to remove funky related slashes and so on. And then that's handed off to normalize, the Path core module in Node that has a normalize function in it. And essentially, what you could think of normalize as kind of what evil is to JavaScript. That is sort of what Path normalizes to string URLs. It kind of goes through all of those dot slash and whatever it needs to resolve and resolves them into the actual URL that should be accessed. So this normalize function takes this and turns this into package.json, which is the path traversaling path. And so the next part of this code, of this ST module, runs this conditional check that essentially tries to see if there's an overlap between the requested URL, which in this case was resolved to /package.json, and what we have defined as the actual public path, which is /public. And so because that doesn't satisfy the condition, it returns a false, and we get a 404. So far, so good. Let's learn about a new trick. This thing called URL encoding, you've probably seen it, you've probably fixed it, you've probably written features around it. Essentially, it's also called known as percent encoding. We can specifically encode URLs or parts of a URL in using a percent encoding kind of style. So dot dot turns into percent to e. If we provide a path and we try to kind of like bypass this whole check that ST has inside, and we now change the path logic of that request from dot dot to percent to e, what do we get? So path name just gets the URL as is, and as it's passed to path normalize, well, path normalize doesn't do anything with percent to e because that's not an actual path to resolve. So this goes as is and stays percent to e. Next up, the rest of this code goes to a function called decode URI component. Decode takes URL encoded parameters, and as is expected, decodes them. So percent to e becomes dot dot slash. So we've essentially bypassed the conditional check for the scope of the path, and now we're already all the way in to just now serving the file, okay, which is a bad thing. So anything here around path join or path resolve, whatever, we've essentially bypassed the whole trick of trying to protect against path traversal attack. And if I send a request with percent to e as a path traversal to a vulnerable express web application that runs ST as a middleware in that specific version, we'd actually be able to access any files that we know their paths to exist on the server. As simple as that. I think part of the vulnerable code is, an important part of it is also learning what is the fix, okay? So the fix that maintainers have applied in this case has been removing the path normalization to begin as a first thing to do, and then instead trying to, I would say, decode it. Might have been probably using the decode URI has probably been potentially a better way of doing it. But there are some regexes that essentially try to do the same thing. They try to decode percent encoded characters and then apply the normalization. So the normalization can actually take effect and not be bypassed. So this is the fix. And I think at this point, we're already learning how to get it right. So first off, there's not just using the right APIs, but also the order of the APIs really matter. So first off, you should probably do decoding of the URI, then apply path normalization, and then the further out related functions, that's of course very related to whatever application logic that you want to apply, whether you want to join it, concatenate it with resolve or something else. And there's a handy function which I haven't seen many people use, that's path.relative, which the idea is, of course, checking that a directory is a relative to a parent one, and that's kind of help you out to understand and ensure that a directory is really a part of a scope that you want to apply as the root of the project. Well, this has been fun, but also beyond NPM packages being vulnerable or vulnerable code that maybe we write, what about path traversal in VS Code extensions? Now, that's an interesting story. So let's see an example of where a VS Code extension might be vulnerable to path traversal, and where does that actually meet us? Because that's not any deployed codes anywhere on production. That's just an extension on my IDE and my computer. So essentially, we'll see how this can actually escalate into gaining sensitive information from our systems. So here is open in default browser. That's the name of the extension. It's as simple as basically right-clicking any HTML file or whatever, and it will open it in the browser. So, makes sense. It's a tiny add-on to VS Code, but it is a popular one, right? It's one that gets downloaded about 1 million times off of the marketplace or installed at this point in time. But behind the way that this VS Code extension works is the fact that it actually spawns a local HTTP server to serve you with that file that you actually want rendered on the browser. So the Snyk security research team has actually, last year, did a bunch of research around VS Code extension marketplace and what can we find there. If there's like malicious things, if there are vulnerable things, and what's the extent and the scope of it. And we've actually found that this was vulnerable to Path Traversal and could be exploited by malicious actors. Let's see how and dive into this. Let's see if I get the video working. Maybe no. See if I can find it on my drive. All right, so let's do something else, which is to play it from my drive. All right, so what's going on here? So this is a video showing you the exploitation taking place. On the left side of it, you see, of course, the IDE working out, and then on the right side, the browser. So I'll take you through it because this is like a very fast-tracked video. Essentially, we're going to have an index file, HTML here. Developer does, open in default browser like the extension works, and you can see it rendered on the right, so far, so good. Now, the attacker opens up 3 sub-terminals here. One of them is basically showing you how they serve a local file to be available. So you could see that PHP thing running up. Then they use ngrok to serve that file over the network. So you understand this isn't any local attack. This is anyone who's basically able to send you a link. And at the end of it, on this left side here, I know it's a bit small, but essentially what it shows is the current directory having just 2 files. So the attack comes down to the fact that if I, as an attacker, can send any of you here who use VS Code and have this extension open and installed in your browser, a link to click on, the only thing that I need you to do is visit that link. It's basically a 0-click exploit. You just click on it, it opens up, and at that moment, I have access to anything you have on your computer. Let me show you how that works. This is now tricking the user. So, for example, a phishing attack that has been, the user has actually been tricked to fix it, which I can easily fool all of you if I'll tell you there's a new runtime that's even 100% faster than Bun, right? Everyone here clicks on it. So you click on it, your browser opens, you see something, maybe it gets closed very fast. I don't know if you caught the fact that file was automatically downloaded to the server. This is a very kind of elaborate attack of how this actually works with iframes and cores and stuff like that. But after that, you could see now, the files on disk has actually been added. There's now a new keys.txt file, potentially an SSH key that was on your host, and I've now been able to transfer it to mine. The only thing that I needed you to do is have this VS Code extension with a vulnerability exist, running in your VS Code, and get you to visit a link. That's the only thing I needed to do to steal files and credentials from your local development environment. So with that said, getting back to why does this happen? Let me go back here. There we go. So why is this happening? Let's look at a vulnerable VS Code extension. Maybe you've already kind of caught it of what's happening here. Kind of highlighting the best part of it. It's decoding the URL. So if I'm trying to access %e, whatever, and private SSH key on the server, it's getting decoded to the .. of it. And then it's getting basically joined and concatenated through path resolve to the root path of wherever I work. So for example, for me, it might be /home, Liran, /projects, repos, whatever, of where I'm running this farm, and I can essentially access anything. As you can see, there is no validation of whether people should actually access files beyond the root path. It's just served as is. Okay, so this is why this has been happening. Okay, oh, now we have the video. I think we can skip that. So this is a very, I would say, a very elaborate attack in the way that it actually works. If you want to understand all the tidbits and how this zero-day exploit works, which is a very, very interesting part of how to combine some HTML tricks and JavaScript tricks to bypass cores and things like that. There's a whole security research done there. Ping me afterwards. I'm happy to share the link too. You can quickly take a picture as well. The thing is, this vulnerability is something that this should get this specific issue, all of us here kind of like a bit worried about this, right? Why is it? It's because this is happening in VS Code, right? Essentially, there's no one auditing VS Code marketplace extensions. What happens if they have more severe vulnerabilities, which are like more specific, potential malicious packages in there, right? There's no CVE for it, which then these two red flags combined together actually address the third flag, which is the fact that, well, there's no alert mechanism. CVEs that we get when we do a Snyk test or an NPM audit on the CLI, we get the vulnerability and the CVE. That's a mechanism that is also helpful for you to understand and be alerted that there's like a potential security issue here. There's nothing here that actually checks VS Code extension, and I'm not talking about other extensions, IDEs, different language ecosystems, other places where this is happening. In fact, when we talk about supply chain security, and you hear that term getting thrown around a bunch these days, I think to an extent what I'm really worried about is not just the productions and the CIs, and that is all very, very important, but also the fact that we as developers are being actively targeted by malicious actors because of what they can gain if they are able to access our systems, okay? As developers, we may have API keys lying around, we may have, .npm token lying around, they can publish packages for us and do a bunch of really, really, really bad things if they can access our laptops. Well, how about Path Traversal in the Node.js runtime? I mean, we've seen it in NPM packages, we see how it can happen in our own code, we've seen it in VS Code extensions. What about the runtime itself? When we update Node because it has incredibly new features that are amazing to update for ESM, for watch, for tests, and whatever, this is all really great. And we mostly upgrade probably because of this. But how often do you actually take notice to upgrade because of a new security release that was sent out? And there's a bunch of really smart and hardworking people here in the summit that are working towards making that happen and making those security releases happen. So here's why this is important. A vulnerability in Node.js of a specific version is able to lead to a flaw of the logic that was applied in one of the path core modules, specifically in a function called normalize string POSIX, which is part of the permutations of different OSs and how they normalize strings. And this isn't supposed to be readable because I wanted to make this complete. This isn't the entire fix that was made to make that vulnerability mitigate. And so you could see how it's not a lot of code, but the subtle differences, right? The code paths that need to be taken to handle // is very nuanced, and it can be mistaken. So specific modules who rely on how this validation actually works would be vulnerable to path traversal attacks. So how does it look like in practice without going through the code at this point? So imagine you have this path, data/foo, data/whatever. What you'd expect from a runtime that's running okay with own vulnerabilities is it actually resolved to this /etc password path. But the vulnerable version of the Node runtime at that point was actually giving you a different result. And if you take that and combine this with other path-related APIs like path join or path resolve, you can see how an example is given where you could serve files from /public and then normalize the path for it and whatever, which is an okay thing to do after you decode it and whatever. But the runtime doesn't work as expected, and so the expected result is not really what's returned for you. You actually get different results, and then they are served to you. So any logic that tries to also try to contain them doesn't really work well. And this is really only applies to specific modules that use this in the ecosystem. So let's imagine that we have Express here again for the sake of things, and this simple Express or Node application is enough to show you how this actually works. If I simply use the Express static one as a middleware to serve static files to my server, you could see like I'm using not vulnerable Express version. There's no code security issues here. There's no npm dependency vulnerable here. It's nothing, right? The only thing I need to do is send off very specialized curl request and HTTP request to the web server, and I will be able to traverse because of the way that the Node runtime is vulnerable, be able to traverse it and actually access this. So I wanted to show you how this actually works in practice. Let's see if the demo here works well. Let's get this one out. All right, so hopefully my IP hasn't changed. Let's see. Set this one. So we're at 10.10.180. Okay, cool. So what we have is, bring that up a bit. So you could see an example of how I Dockerized, the Node.js runtime in a simple application. This is essentially what it is. And what I want to show you is there's a tool, a fuzzer tool, that is called .pun. As you can understand, it's a very kind of like, offensive security tooling that tries to fuzzy test, essentially send a bunch of strings to a server, and hopefully it finds path traversal attacks. So you don't even need to work really hard. The funny thing about this tool is it exists since like 2011 or 2012 or something like that, and has been shown and showcased at like Black Hat and things like this. It gets a bunch of really, really nice and useful command line flags that you could actually apply and be able to kind of like remove all the false positives. So I could go ahead and run it. This is the command itself. This is the server running on the left there, and this is on the right me trying to run this command. It has went through all the permutations. I can see the IP I think is the same, hopefully stay the same. And if I'm ready to launch it, I can press return, and it starts and sends all of those strings, right? So like that's gonna take a few minutes. Specifically, this takes 5 minutes, so I didn't want to do that. All of you wait for it, but you can see that when it was done, after 5 minutes and 55 seconds, it had completed and found this kind of URL to be vulnerable. So I can take this URL and apply it here, and there we go. We accessed etc hosts on my container running a vulnerable Node version due to path traversal. Okay, that's the only thing that needed. We have automated the whole thing. It didn't need to be any smart person. I just Googled, path traversal fuzzing tools, found it, installed it, whole thing done. So, luckily for us, this vulnerable version is back in 8.5.0. According to a report that Bet Griggs, which so thankfully have created a while back, the downloads count from the official Node kind of like repository, the website thing, say that Node 8 versions are downloaded about 1.5%. So there are 1.5% versions, installed versions of on the internet of this. I don't know if it's 8.5.0. But this specific vulnerability exists and affects that one, and there are potentially servers running this and may be vulnerable to it. So this is an important thing, please update. So summarizing with some learnings, we've seen how path traversal is very much everywhere, right? It's like VS Code extensions, dependencies, code, runtimes. I've got examples from routers being vulnerable to path traversal attacks and whatever you can do with those. It's also easy to confuse, right? The nuanced differences between how to use correctly those kind of file path APIs that are very important are not something that we all understand. And it's a doorway in, because I've been shown you that I can access the etc host file on the container. I can also access package.json or whatever, and then escalate the attack to things that are more impactful. So in my opinion, this is kind of like my take of it, kind of like the severity of Path Traversal vulnerabilities very much compounds with the more insecurely built applications, right? So the more that the application itself is built with insecure things, like you store secrets in your file system and stuff like that, this vulnerability compounds to more and more aggressive attack vectors. So I would say, what is the path to no Path Traversal at this point? Well, obviously, us learning and being more aware of this helps. If I had used, for example, the Snyk VS Code ID extension, which is freely available to install it from the marketplace, what it does is runs code security tests on your code. So you can see to the right pane, I've actually went in and showed you the st vulnerable function of getPath. I then copy-pasted that into a very vanilla kind of Express server and middleware and just put it right there. The moment I pressed Command Save to save that, the VS Code extension kind of went up. Snyk scanned the code and told me, hey, you have a vulnerable code there, right, for Path Traversal attacks. So it actually helps you and us as maintainers and as developers of open source packages or at work to really find code security issues. Remember the VS Code Marketplace extension that was vulnerable? Well, we actually ran a check for that one too. So Kirill was a former security researcher at Snyk, had actually cloned that open in default browser vulnerable version that was susceptible to vulnerable Path Traversal attacks. He just used the Snyk CLI thing as a quick one, just ran Snyk test on the code base, and again, ultimately finding Path Traversal attacks in that. So it actually helps us write secure code and find it. And of course, at the end of it, not everything can be very well automated. Hopefully, at some point it is. But putting up resources for all of you, and you being here, learning about Path Traversal attacks and other security issues in Node is very, very important. So that you can just Google Snyk learn and learn a bunch of really cool path through interactive modes and things like that. So with that, hopefully we're all aware of what Path Traversal vulnerabilities are, how they can escalate, and hopefully how to mitigate them. So thank you all very, very much, and hope you enjoy the conference.